Namaste, welcome to the Group 1 Services Mains Examination telecasted by TSAT. We are going to discuss about the concept is called data interpretation and problem solving. As you know that we have 6 papers, each paper consisting of 150 marks. So, in paper 5 we have 2 areas, one is science and technology and other area is data interpretation and problem solving. So, we have 3 sections in it, the section 1, section 2 concerned to the science and technology and section 3 based on data interpretation and problem solving. So, here we have 5 questions in section 1, 5 questions in section 2 and 5 questions in section 3. But when you observe the section 3, so sometimes they may ask direct one question for 10 marks and sometimes they ask one question having 5 sub questions. In this scenario, each question carries 2 marks because they will ask the questions mostly on line graphs, pie diagrams, bar graphs, table interpretation, time and distance, and ratios and proportions, profit and loss, compound interest, simple interest, like various arithmetic concepts also. So, generally they will ask for these areas for 2 marks question. That is the most probable option is each question has 5 sub questions and each question will carry 2 marks, 5 2s are 10 marks, totally 50 marks for the section 3. So, now in this session we are going to discuss about the ratios and proportions. Then what is the ratio? This is a very important. In a certain situation, the comparison of 2 quantities by the method of division is very efficient. We can say that comparison or simplified form of 2 quantities of the same kind is referred to as ratio. For example, 20 rupees and 100 rupees. So, when you compare 20 rupees with 100 rupees, 20 is 1/5 of 100 rupees. So, the ratio you can say is as 1:5, correct. For example, if you say 30 minutes and 1 hour. So, 30 minutes and 1 hour means for 1 hour it has 60 minutes. So, means 30 60 means 60 is twice of 30 minutes. So, we can say as 1:2. Are you able to understand? So, this is very important, means for certain situations, for certain conditions, we have to compare the quantities with the division simply. We can call it as simply as a ratio as we will say as A is to B. It means A by B, or you can say like also. So, we will write in a different formats, but mostly frequently used is to. This is the symbol to represent the ratio. And this relation gives us how many times one quantity is equal to other quantity. When you compare with the meter and kilometer. So, for 1 kilometer there are 1000 meters. So, 1:1000. Paise and rupee 1:100, correct. Like we can say, for example, if you say as a CGS units and SI units. CGS units we will say for the force, CGS units we will say for the force as dynes, and for MK units it is Newton. So, we can say 1 Newton is equal to 10 to the power 5 dynes. So, we can say when you compare this we will say 1:10⁵, like so many comparisons. So, for how many are equal to this one. So, compare Fahrenheit to degree Celsius and degree Celsius to Fahrenheit, like any concept, any quantity, just we are comparison in the form of division, that will be considered as a ratio. Okay. The ratio is a number that can be used to express one quantity as a fraction of other ones. Clear? If for example, if you say as 10 millimeters equal to 1 centimeter, it means 1 by 10 centimeters equal to 1 millimeter, means 0.1 centimeter is equal to 1 millimeter, correct. So, just it is a fraction, we expressed millimeter in terms of centimeters, means 1 by 10 centimeters. Are you feel correct? So, in this way we can express a ratio in the form of a fraction. Okay. The two numbers in the ratio can be compared when they have the same unit. This is a very important note. So, when you compare with the two quantities, the essential thing is both should be in the same unit. Previously I said, so means here one is millimeter, other one is also should be in millimeter, correct. One is kilogram, other one will be also kilogram. One is represents, for example, one is represents meters, other one represents kilograms. There is no comparison between these two quantities, one in terms of length and another in terms of mass. So, very important thing is when you compare the two quantities, it should be in the same unit. We make use of ratios to compare two things, then the sign generally will use the is to, just what I said. This simply is to is the symbol. Okay. Now, coming to this, a ratio can be written as a fraction, says 2 by 5. We happen to see various comparisons or say fractions rations in our daily life. For example, A to B. A to B is simply as we can say A is to B. So, see, A to B we can call it as A to B, A is to B, A by B. These are the three forms to represent the ratio A to B, A is to B, A by B. So, we can write it as 2 by 5 as you can write as 2 is to 5 also. Okay. So, that is a relation between these are different forms of the ratio. Okay. So, are you understand the three forms are three different forms, one is A to B, A is to B, A by B. So, what you have to remember, the key points to remember for the ratio, that is the ratio should exist between the quantities of the same kind. While comparing two things, the units should be similar. There should be significant order of terms. The comparison of two ratios can be performed if the ratios are equivalent like the fractions. This is very, very important. So, we have very important points to remember for about the ratio. The first one is the ratio should exist between the two quantities of the same kind. Just now I said. So, if you say with respect to mass, you have to say with respect to mass. So, in 2 kilograms and 30 minutes, there is no ratio between these two. So, 30 minutes is meant for the time and 2 kilograms is meant for mass. So, mass and time are two different quantities. So, we can't compare or make a ratio between these two different quantities. It's clear? Both should be same kind, means 2 kilograms and 75 milligrams. When you compare these two, because 2 kilograms and 75 milligrams both are represent the mass or weight of the object. So, that is you can compare it, clear. So, like the both should be of the same kind, quantity should be same kind, that is the first one, and there should be significant order of terms. So, this is also a very, very important, and comparison of two rates performed ratios are equivalent like fractions. So, both should be equivalent like fractions. Okay. Now, what is the definition of proportion? So, about ratios, now I gave a little idea about the ratio. Now, shifting to the proportion. The proportion is an equation that defines that two given ratios are equivalent to each other. When A is to B and C is to D both are equal, then A is to B is in proportion to C is to D. So, I will give a small example. So, because a proportion has a lot of application in the various branches of science, not only in the branches of science, everywhere in every branch of mathematics, science and other fields. So, if you take it as a Boyle's law, the pressure of the gas is inversely proportional to the volume of the gas. When pressure increases, volume decreases. So, we can say P is proportional to 1 by V. This is Boyle's law, correct? Okay. So, when you come into the electricity, when you at a constant temperature, so simply you can say is when potential difference increases, the current flow through it also increases. V is proportional to I, or we can say is V equal to Ri, correct? So, this is called Ohm's law in electricity. Like we can say so many concepts of physics. So, all these based on a proportion. So, here the proportion is an equation that defines the two given ratios are equivalent to each other. In other words, the proportion states the equality of two fractions of the ratios in proportion. Two sets of given numbers are increasing or decreasing. Okay. So, I will give a small example, that is a kilometer per hour, meter per second, kilometer per hour, meter per second. So, like if you can consider, so as when you compare a distance and speed, as speed increases, so distance covered increases and remaining distance will be decreases. Are you understand? So, here sometimes if one quantity increases, other quantity decreases. If one quantity decreases, other quantity increases. So, there is an inversely proportionate between these two. If one quantity increases, other quantity also increases. If one quantity decreases, other quantities also. Okay. If the number of earning people in a family increases, the total income of the family also increases, correct? Okay. If the number of family members increases, the expenditure occurred in the family also increases. This is called directly proportional. Okay. So, if the number of family members increases, the food grains in the family will be decreases. The stored food means as the people are increasing, the stored grains will be decreases. Am I correct or not? So, like when you compare these quantities means how they are increasing or decreasing. So, that information will be given in the form of a proportion. The ratio and proportion are said to be faces of the same coin. The ratio and proportion are said to be faces of same coin. You can't divide these two. When two ratios are equal in value, then they are said to be in proportion. So, in simple words, it compares two ratios. Proportions are denoted by the symbol as is as. So, means here ratio will be this and proportion will be shown in this one. This is called is as, this one is. So, this is the symbol for ratio and this is the symbol for proportion. So, we can understand the difference between these two. So, actually comparison of two ratios is called proportion, that is it. The relation between ratios and proportion. So, this is a very important and you have to change your mindset, that is you are shifting from objective pattern to descriptive pattern. So, obviously here so answer will not give a very important role, because their answer is very important. Here the solution method is very important, how we are going to present the solution in the examination, that is a very important in a descriptive mode. So, the conceptual understanding is highly essential for this examination. Okay. Now, the proportions can be classified into three categories actually. One is called direct proportion, second one is called inverse proportion, of course some mixed proportion, that is here a continued proportion I have given here. One is called direct proportion, second one is called inverse proportion, third one is continued proportion. Just now we are saying a direct proportion. If there are two quantities, if one quantity increases, other quantities also increases, or one quantity decreases, other quantity also decreases, they are said to be in direct proportion. If you say A and B, when A increases, B also increases. When A decreases, B also decreases. Then you can say simply as A is proportional to B. Clear? Just now when said so Charles' law, when you take it as a chemistry, in Charles' law, so there is a V is proportional to T at constant pressure of a gas. When temperature increases, the volume also increases. When temperature decreases, the volume also decreases. Here one quantity increases, other quantities also increases. One quantity decreases, other quantity also decreases, then that relation is said to be simply as direct proportion. Clear? Simply A is proportional to B. Like when A is proportional to B, we can say it as A is equal to KB, or like A equal to KB, or A1 is equal to KB1. When A2 also proportional to B, A1 is proportional to B1, A2 is proportional to B2, means you can say A2 is equal to KB2. So then you can say A1 by A2 is equal to B1 by B2. If A1 by A2 is equal to B1 by B2, then we can say those two quantities are in direct proportion. Or A is proportional to B, then you can say as A equal to KB, that is K is a proportional constant. Clear? That is called direct proportion. Now coming to the inverse proportion. So inverse proportion, when you come to the inverse proportion, if one quantity increases, other quantity decreases, then it is called inverse proportion. Or one quantity decreases, other quantities increases, then that. So means simply you can say A is proportional to 1 by B. A is proportional to 1 by B. When you take the resistance of a body with respect to electricity, when the resistance directly is proportional to R is proportional to L. The resistance of the conductor is directly proportional to the length of the conductor. Okay, and R is proportional to 1 by A. As the cross section area of the conductor increases, the resistance is decreases. So one quantity increases, other quantity decreases. Already I said P is proportional to 1 by V. At constant temperature, when the pressure increases, the volume decreases. This is called Boyle's law. Clear? So like you can say about inverse proportion. So means when P is proportional to 1 by, then we can say PV is constant, or you can say P1 V1 is equal to P2 V2. P1 V1 equal to P2 V2. That is called inverse proportion. Now continued proportion. So before going to discuss all these things, I will discuss one by one once again. The direct proportion describes the relationship between two quantities in which the increases in the one quantity, there is an increase in the other quantity also. Similarly, if one quantity decreases, other quantity also decreases, and A and B quantities is said to be A is proportional to B. This is A is proportional to B, or you can say A equal to KB, or A1 B1. Okay, A1 B1 is equal to A1 by A2, A1 is equal to KB1, A2 is equal to KB2, A1 by A2 equal to B1 by B2, or you can say A1 by B2 is A1 B2 is equal to A2 B1. In any format, you can say this as when they are in direct proportion. Is it clear? Okay, now shifting the next. Inverse proportion. Inverse proportion describes the relationship between two quantities in which a an increase in the one quantity leads to decrease in the other quantity. Similarly, if there is a decrease in one quantity, there is an increasing in the other quantity. So, we can say is A is proportional to 1 by V. Just now I discussed about the Boyle's law, and of course, we can say as Ohm's law also, like and the properties of resistance also, as the cross sectional area of the conductor increases, the resistance of the conductor decreases. Correct or not? In volume and density, what is the density? Density is mass by volume. Correct? When the volume increases, the density decreases. When the density increases, of course, decrease the volume increases. So, we like you can say as inversely proportion. So, we can give n number of examples of the inverse proportion. Now, coming to the continued fraction or mixed fraction, that is A is to B and C is to D are two ratio. In order to find the continued fraction, if two given the ratio terms, we convert the means to single term and number. This should be a general LCM of means. The given ratio LCM of B and C will be BC, correct. Thus, multiplying the first ratio by C and the second ratio by B, we have A. There is a, for example, A is to B is there. Multiply both with the letter C, then we can say as AC is to BC. This is the first ratio. And other ratio, what is the other ratio here? C is to D is another ratio. Multiply both with the B, that is BC is to BD. So, here AC is to BC is ratio, here BC is to BD means AC is to BC is to BD. So, this is called a continued fraction, continued proportion. So, Y is to B is one ratio, C is to D is another ratio. By considering these two ratios, we will make a continued ratio, that is multiply A is to B with C, then it becomes AC is to BC, multiply C is to D with B, then it becomes as BC is to BD, then it becomes AC is to BC is to BD. AC is to BC is to BD. Clear? In this manner, you can say as a continued proportion. So, there are three proportions, as you know that one is called direct proportion, second one is called indirect proportion. Of course, as inverse proportion, the third one is called a continued proportion. Clear? Okay. So, what is the ratio formula? This is a very important. We assume that we have two quantities, two numbers or two entities, and we have to find the ratio of these two. Then the formula for the ratio defined as A is to B, you can say as A by B, correct. So, where A and B could be any two quantities, the same quantities, and A called, the first term is called, here the terminology is very important. In A is to B, the first term is called antecedent and second term is called consequent. So, this terminology is a very important, antecedent and consequent. So, we have to know which is the first term and the second term. Okay. When 4:9, for example, we can write as 4:9 as 4/9. 4:9 you can write as 4/9, correct. So, in the 4/9, the first one is antecedent and the second one is called consequent. So, generally in a fraction, the first one you call it as numerator and the second one is the denominator. This is a ratio, no. So, we can say is antecedent, other one is a consequent. Is it clear? Okay. So, very important thing, what is a proportional formula? Now, let us assume that the proportion in two ratios, that is A is to B is one ratio, C is to D is another ratio. The two terms B and C are called means or mean terms, whereas A and D are known as extremes or extreme terms. So, means here A is to B, for example, A is to B is one ratio, C is to D another ratio. These actually these B and C are called means, and A and D, these two are called extremes. Okay. So, extremes. So, the product of means is equal to product of extremes, means AD is equal to BC. The product of means is equal to product of extremes, then simply we can say that the two ratios are in proportion. Okay. For example, the number of students in a classroom, first the ratio of number of girls to boys is 3:5 and the other is 4:8. We can write it as 3:5 is as 4:8, correct. 3:5 is as 4:8, means 5 4s are 20, 3 8s are 24, means 24 and 25. So, now the 3 and 8 are extremes while 5 and 4 are means. The ratio value does not affect when the same non-zero number is multiplied or divided on each term, clear. So, when A is to B and C is to D are in proportion, then AD is equal to BC, clear. Okay. Now, we are going to discuss about the very important properties of proportions, that is called one is called addendo. Addendo means when A is to B is equal to C is to D, then when you can compare A plus C is to B plus D. Subtractendo, that is A is to B equal to C is to D, then A minus C is to B minus D. Okay. This is rarely used, but most frequently used things are first dividend. When A is to B is equal to C is to D, correct. So, means here A by B is equal to C by D, then you can say just subtract 1, A by B minus 1 is equal to C by D minus 1, or A minus B by B is equal to C minus D by D, or you can say A minus B is to B is equal to C minus D is to D, clear. So, this is called dividendo. So, means subtract 1 from the both the ratios. When A is to B is equal to C is to D, subtract 1 from it, then A minus B is to B is equal to C minus D is to D, then it is a dividendo. Componendo, when you get this componendo means here you have to add 1 to it, means A by B is equal to C by D, add 1 to it, A by B plus 1 C by D plus 1, means A plus B by B is equal to C plus D by D, or A plus B is to B is equal to C plus D is to D, that is it, clear. This is called dividendo. Componendo. Later, alternando means here when A is to B is equal to C is to D, means A by B is equal to C by D, then you can say A by C is equal to B by D. This is called alternando. Invertendo means you are taking the reciprocal of that one. Then A is to B is equal to C is to D, invertendo, inverse means B is to A is equal to D is to C, invertendo. Now, the last one is a combination of componendo and dividendo, means A plus B is by A minus B is equal to C plus D by C minus D, means here A plus B is to A minus B, C plus D is to C minus D. These are the different properties of the proportion. So, you have to remember this one here. Dividendo means A is to B is equal to C is to D, then A minus B is to B is equal to C minus D is to D. Alternando means here simply you can say it's A is to B equal to C is to D, then A is to C is equal to B is to D. Invertendo A is to B is equal to C is to D, then B is to A equal to D is to C. Componendo and dividendo means when A is to B is equal to C is to D, then A plus B is to A minus B is equal to C plus D is to C minus D. These are the different properties of proportions. Is it clear? So, now we are going to discuss about all this. Now, this is the conceptual area of ratios and proportions. In the next session, we are going to discuss about the ratio and proportions, the problems already asked in the previous examinations and expected questions also. We will discuss those things in the next session. Until thank you.